Hello everyone. Today I am going to solve the Codeforces problem. This is a 2000 rated problem. I was just randomly solving some problems, so I decided to make a video on this for practice. Let's first read the problem. You are given an array of integers and an integer x, and you have to select the maximum number of elements in this array such that each subarray containing exactly more than one element, either at least one element of this subarray is not selected, or the sum is greater than equal to x multiplied by its length. So what we have to do is basically pick some elements from the array such that after picking, let's mark that indices that we have picked, and after that every subarray of length greater than or equals to 2 either either contain one indices that is not marked, or the sum is basically greater than x multiplied by its length. So how to approach this problem? You can pause this video and try it yourself, and then we will look at the solution. So let's try to understand this constraint, how to check this easily. You can see that we can rewrite this expression as we'll take this RHS into the left hand side, and then uh, we have x number of we have x uh, length times, means if we subtract x from each of these elements, then our condition is converted to some other which is basically the sum is greater than equals to 0. What I am saying that if you subtract x from each of these element, then this condition, and then take the sum, then their sum, if their sum is greater than equals to 0, then that condition and this condition is same. Let me write it. Is greater than equals to x times of r minus l plus 1. So you can write this as take this x, this RHS left side, and rewrite this as x plus ar 6 greater than equals to 0. So now modify the array and subtract x from each of these elements, and then you can check the second condition very easily. Either the sum is, if the sum is greater than equals to 0, then you are done. So this can be now this is simple. Let's let's in every question we have to find some loopholes or some condition. So here, how to so technically for each array, so let's suppose we are picking L to R. Suppose we marked we selected some indices which are continuous. We can do that. So now if I am selecting all the elements belonging to the subarray from L to R, then is it possible to select the whole subarray? So if L should be less than R, and each subarray present in this L to R element should satisfy this condition, because the first condition is violated. We have selected all the elements. What I am saying is, suppose that we have these elements x, y, z, a, and then b, and we selected all of the elements. So what condition they have to satisfy the second condition, means all of the subarray of length 2, length 3 and length 4 and length 5 should be greater than equals to 0 after subtracting x from these elements. Now this condition is equivalent to saying that if uh, the sum of length 2, each subarray of length 2 and each subarray of length 3 is greater than equals to 0, then this is equivalent of saying that each subarray will have sum greater than equals to 0. How? Suppose now what I am saying that all 2, 3 length subarray have sum equals to 0. Obviously you first subtract x and then you take the sum. Okay. Now what I am saying that if this condition satisfy, if a subarray satisfy this condition, then all other subarray will have sum greater than equals to 0. How? If you take a 4 length subarray, then obviously you can partition this into 2 and 2 subarray, and both subarray have length greater than equals to, sums greater than equals to 0. So the collectively their sum will be greater than equals to 0. Now take 5. You can write 5 as length of 2 subarray and length of 3 subarray. So this is also we know that all of the subarray of length 2 has sum greater than equals to 0, and also for length greater than equals to 3. So this is so our condition is reduced to uh, uh, basically this can be easily checked by if we are selecting all of the elements belonging to range L to R, then we have to simply check whether all 2 length and 3 length subarray have sum greater than equals to 0 or not. So now how to approach this problem. Now we have uh, some uh, results we can use to simplify our problems. Now what I am trying to do is basically at each index I have two choices, either select or not select. So let's make a dp of I comma 0. What this will do, this will check whether if I am not taking ith index element, then what will be the maximum number of elements that I can get, maximum number of elements that I can select from the prefix 1 to I. So and dp of I comma 1 will tell that if I am going to select this current element, then what will be the maximum selection we can do. So dp of I comma 0 is simply the either I can simply right, either we can take the previous element or not take the previous element and then take the maximum. Yeah, right. And for the second one, how to evaluate this? If I am taking the current element, so obviously you will find one solution that mm, from I we can take some elements, some from I we can move back and then try to take some continuous elements. Suppose you choose j less than I, and suppose you choose up from j to I, that I am going to pick j to I elements, and then I will not pick j minus I one element, and then we continue, right? So what? So first, if you are only you will only able to take uh, all continuous elements from j to I if and only if this the subarray j to I satisfy this condition, right? Now uh, suppose we have already checked that j is that index j satisfy that condition. So now how dp of I comma 1 will look like? If I comma 1 will look like out of all j, out of all j we have to take maximum, and then dp of j minus 1 we have to exclude the j minus 1 element and add I minus j plus 1 length, right? We have to take maximum j for all such j which satisfy this condition, and we have to take the maximum to calculate dp of I comma 1. And but for finding all j we can optimize it by using set, that we store the this value like dp of j minus 1 comma 0. Let me write it. You can also write this as dp of j minus 1 comma 0 minus j minus 1, and you can take I out of I from the condition, I from this expression. Now you can see that dp of j minus 1 and this indices. So basically you can maintain a set in which you can store dp and minus its index, and you pick the maximum and then you can evaluate, and you can do that, like you can do like that. But one point to notice here that for j, if you like check the optimal j will be close to I, right? The optimal j will be close to I. Like j can be, the optimal j can be either j minus 1, the optimal j can be either I or I minus 1 or I minus 2 or I minus 3. Yes. Yeah. If you check on only these j, then your problem is done. We have to check for only these values of j, right? Because kind of again this property hold there, kind of if we are taking two elements and then we are leaving, technically what I am trying to explain that, let's suppose we have chosen the I minus 2th element and then I minus 1th element and then ith element. So the I minus 3th element, I minus 3th element is basically if you have selected I minus 1 and I minus 2, then for I minus 3, I minus 3 is independent of I. Whether you will take I minus 3 or not is only dependent on I minus 1, because I minus 3 for length 3 will come to I minus 1, and for length 2 it will come to I minus 2 only. So this is technically you take I and then you try to, like you can understand that taking this one or this one will help, right? So let me show my code and then you will better understand this part. So I have taken the vector as an input and then x, and here is the deep I have created. So if I equals to 1, then the first dp of I comma 0 is simple. Either you take the previous element or not take it. If I equals to 1, then obviously there is only one choice. You select it, which is maximum. If I equals to 2, then if you can take both element. When you can take both element, if sum minus 2 times of x, this is basically this condition. This condition. Then I can take the both element, or I can take one element, the current one. If I greater than equals to 3, then I am checking whether I can take the 2 element. If I cannot take the 2 element, then I have my j will be I minus 1. J will be I, and then I have to I don't have to take the I minus 1th element, and I will add 1 because I have taken one element and the previous maximum. If I can take 2 element, then I will check whether I can take 3 element. If I cannot take 3 element, then what I will do, my j will be I minus 1, and then I will do this. Otherwise I will do this, uh, which you can understand simply, like this is not very hard to understand. If you try to understand or try to run some test case, then you will understand why I am doing this. Okay, then so try to, you can also try to write non-optimal like analog and approach, which is done by using set, and yeah, you can now yeah, I think this problem is solved, and you can try it, you can write its code later on. Okay, thank you.